Hi guys, last time we talked about torque and the inclined torque. So today, I'm going to discuss about the different forms of energy. First, the electrical energy is energy newly derived from electrical potential energy. When loosely used to describe energy absorbed or delivered by an electrical circuit. It also refers to energy which has been converted from electrical potential energy. This energy is supplied by the combination of electric current and electrical potential that is delivered by the circuit. So let's have an example. Second, radiant energy is the energy of electromagnetic waves. The quantity of radiant energy may be calculated by integrating radiant flux with respect to time, and like all the forms of energy, the system unit is the joule. The term is used particularly when radiation is emitted by a source into the surrounding environment. Radiant energy may be visible or invisible to the human eye. Also, the term radiant energy is most commonly used in the fields of radiometry, solar energy, heating, and lighting, but is also sometimes used in the other fields, such as telecommunications. In modern applications involving transmission of power from one location to another, radiant energy is sometimes used to refer to the electromagnetic waves themselves, rather than their energy. In the past, the term of radiant energy has also been used. So this is the example. Visible light, a form of radiant energy, is scattered by the fog in a forest. Next is thermal energy. Is the part of the total potential energy and kinetic energy of an object or sample of matter that results in the system temperature. It's also the portion of the thermodynamic or internal energy of a system that is responsible for the temperature of the system. The thermal energy of a system scales with its size and is therefore an extensive property. It is not a state function of the system unless the system has been constructed so that all changes in the internal energy are due to changes in thermal energy as a result of heat transfer, not work. Otherwise, thermal energy is dependent on the way or method by which the system attains its temperature. So this is an example of a thermal energy. Next is sound energy, a form of energy associated with the vibration or disturbance of matter. Sound is a mechanical wave, and as such requires a medium to travel through. The sound energy is in a volume of interest is defined as the sum of the potential and kinetic energies, densities integrated over the volume. So this is an example of a sound energy. Next is mechanical energy. This is the potential of a chemical substance to undergo a transformation through a chemical reaction or to transform other chemical substances. Examples include batteries and light bulbs and cells, etc. Breaking or making of chemical bonds involves energy, which may be either absorbed or evolved from a chemical system. So this is an example. Next is nuclear energy. Usually means the part of the energy of an atomic nucleus, which can be released by fusion or fission or radioactive decay. Nuclear energy may also refer to nuclear binding energy, the energy required to split a nucleus of an atom. Nuclear energy sculpture, a bronze sculpture by Henry Moore in the University of Chicago. Nuclear potential energy, the potential energy of the particles inside an atom nucleus. Nuclear power, the use of sustained nuclear fission to generate heat and electricity. Nuclear technology, applications of nuclear energy including nuclear power, nuclear and nuclear weapons. Example: so let's now have the sources of energy. Renewable energy is generally defined as energy that comes from sources which are naturally replenished on a human timescale, such as sunlight, wind, rain, tides, waves, and geothermal heat. Renewable energy replaces conventional fuels in four distinct areas: the electricity generation, hot water, space heating, motor fuels, and rural off-grid energy services. So the wind, sun, and biomass are three renewable examples of energy sources. This is also an example of our renewable sources. The 150 megawatts Andasol Solar Power Station is a commercial parabolic through solar thermal power plant located in Spain. The Andasol plant uses tanks of molten salt to store solar energy so that it can continue generating electricity even when the sun isn't shining. Now let's have the non-renewable energy, or also known as a infinite resource. This is a resource that does not renew itself at a sufficient rate for sustainable economic extraction in meaningful human time frame. So let's have fossil fuel. Natural resources such as coal, petroleum, crude oil, and natural gas take thousands of years to form naturally and cannot be replaced as fast as they are being consumed. Eventually, it is considered that fossil-based resources will become too costly to harvest, and humanity will need to shift its reliance to other sources of energy. So example, coal mining. Next, radioactive fuel. The use of nuclear technology requires a radioactive fuel. Uranium ore is present in the ground at relatively low concentrations and mined in 19 countries. This mined uranium is used to fuel energy-generating nuclear reactions with fissionable uranium-235, which generates heat that is ultimately used to power turbines to generate electricity. So, example, an open pit uranium. Now let's have the law of conservation of energy. The law of conservation of energy states that the total energy of an isolated system cannot change. It is said to be conserved over time. Energy can be neither created nor destroyed, but can change form. For instance, chemical energy can be converted to kinetic energy in the explosion of a stick of dynamite. A consequence of the law of conservation of energy is that a perpetual motion machine of the first kind cannot exist. That is to say, no system without an external energy supply can deliver an unlimited amount of energy to its surroundings. This is some example of law of conservation of energy that can be seen every day. So first, water can produce electricity. Water falls from the sky, converting potential energy to kinetic energy. This energy is then used to rotate the turbine of a generator to produce electricity. In this process, the potential energy of water in a dam can be turned into kinetic energy, which can then become electric energy. Next, when you push a book across the table, the energy from your moving arm is transferred from your body to the book, causing the book to move. Also, when the car hit the curb, it broke apart. Energy from the moving car was transferred to the non-moving cement, causing it to move. Next, when a bowling ball knocks over pins that had been standing still, energy is transferred from the ball to the pins. Now energy is lost. So this law of conservation of energy examples show how commonplace this physics concept is in everyday life.